Today we're diving into the science behind LiDAR, the incredible technology that lets self-driving cars, robots, and even satellites see the world in 3D. But here's a question. How does LiDAR see in the dark? Let's break it down. I'm Ben, this is Physics or Bust. To understand LiDAR, we have to first know how it works. LiDAR stands for Light Detection and Ranging. At its core, it's a system that sends out laser pulses and times how long it takes for the lasers to bounce back. By doing this millions of times a second, LiDAR creates a detailed map of the entire environment. LiDAR uses infrared light beams, which are invisible to the human eye, but perfectly detectable to the LiDAR sensor. So whether it's day or night, foggy or not, LiDAR works the same either way. So let's talk about the physics behind this. LiDAR operates on the time of flight principle. The sensor measures the time it takes for a laser beam to travel to an object and return back. Using the speed of light, we can calculate the exact distance. The formula is simple. D equals c times t divided by 2, where d is the distance, c is the speed of light, and t is the time it took for the laser beam to go out and come back. Since light travels at nearly 300,000 kilometers per second, the timing needs to be extremely precise. Modern LiDAR systems can measure time differences as small as a few picoseconds. That's trillionths of a second. One of the coolest advantages? LiDAR works in complete darkness, but also works in bright sunlight. Unlike cameras, which might struggle with glares and shadows, LiDAR detects objects with high accuracy regardless of lighting conditions. Now, not all LiDAR systems are the same. Some use spinning mirrors to cover 360 degrees at one time, while others use solid-state technology for a smaller, more durable design. Let's look at the physics behind each one of these. First, we'll look at spinning LiDAR, also known as mechanical LiDAR. It uses a spinning mirror or prism to direct a laser beam in different directions. The rotation allows the system to scan a full 360-degree view of the environment. Because the beam physically moves, the data is highly accurate. But the problem with the system is that it does have moving parts, so it does mean that it has more wear and tear and doesn't last as long. On the other hand, solid-state LiDAR doesn't have any mechanical parts. Instead, it uses phased array optics, or MEMS, micro-electro-mechanical systems, to electronically steer the beam without any moving parts. This makes the system smaller, more durable, and easier to integrate into compact devices. The downside is that solid-state LiDAR typically has a smaller field of view than its spinning counterpart, which means to achieve full coverage, the system has to have multiple sensors. So why is this important? LiDAR has turned into a game changer for autonomous vehicles, robots, and even archaeology, surprising enough. To have highly reliable autonomous vehicles, you have to have a system in place that sees really well no matter what the lighting conditions. That's what LiDAR has done for the autonomous vehicle industry. And when it comes to archaeology, scientists have utilized LiDAR to detect cities hidden underneath dense jungle. Now let's tackle a quick myth. Some people think that LiDAR is unsafe because it uses lasers. But don't worry, LiDAR systems utilize eye-safe infrared light, which means there's no harm to animals or humans. So there you have it. LiDAR is giving robots and autonomous vehicles superhuman vision that works 24/7, rain or shine, fog or clear skies. So what do you think? Would you trust a self-driving car that uses LiDAR? Let me know in the comments below. If you enjoyed this video, I think you'd like this book. I have an affiliate link in the description below. I do get a small commission, but it doesn't cost you any extra. For more space and science news or updates, remember to like and subscribe, and remember, keep asking questions. I'll see you on the next video.